climate actually has something directly to do with the sun, with our magnetic field, with volcanism, with our solar system. Ladies and gentlemen, welcome in Robert Felix, the author of Magnetic Reversals and Evolutionary Leaps, The True Origin of Species. He is also the author of Not by Fire, but by Ice. Discover what killed the dinosaurs and why it could soon kill us. Mr. Felix has one of the most compelling synthesis of explaining weather and climate in a way I've never heard before. And while on this show today, we have meteorologists and climatologists who are going to help us understand what weather has to do with. Robert Felix is here today, and he's going to help us understand the truth about climate and weather. Ladies and gentlemen, please welcome Robert Felix. Welcome to It's Rainmaking Time.
Thank you, Kim. I'm really happy to be on with you. And, you talk about what's going on here with the climate, and I just want to start it out by saying it's a cycle, it's a cycle, it's a cycle, and it has nothing to do with what humans may or may not be doing on this planet.
Let me ask you something about it's a cycle, it's a cycle, it's a cycle. In your book, Not by Fire, but by Ice, you speak about the correlation between extinctions and ice ages, and extinctions and pole flips, or magnetic flips, as you call it, every 11,500 years. Can you bring us into the verifiable, evidentiary body of knowledge that needs to be articulated to even have a frame of reference to be discussing the subject?
Well, there's a cycle called the Milankovitch Cycle, and this cycle, I really don't know of any geologist in the world who would disagree with this cycle. And the cycle, it's not something I've invented. We've known about it since at least the 1970s. In the 1970s, there was a group called Climate Long Range Investigation, Mapping, and Prediction. And it was spearheaded by people at Lamont Doherty Earth Observatory. It had more than 200 institutions involved. What they did is they drilled cores into the ocean floor where they could look at sediments that had been deposited as much as 500,000 years ago. And they discovered that ice ages have come and gone, according to a cycle, approximately every 23,000 years, with a smaller ice age at the halfway point every 11,500 years. So I look at this cycle every 11,500 years where the climate warms up to periods of warmth even warmer than today, and then we descend into an ice age almost instantaneously.
And talk about the instantaneously, because what blew my mind reading the book was that it doesn't have to get that much colder to move into an ice age. What do you mean?
It's already cold enough. Going back to Lamont Doherty Earth Observatory, the head of Lamont Doherty Earth Observatory back in the 1970s, a guy by the name of Morris Ewing, said, it's cold enough right now to have an ice age. All we need is more moisture. And boy, have we been getting it. It's I believe that precipitation has increased in the United States by more than 20% since Morris Ewing said those words. So to me, I see it happening right now. And when I say fast, when I went to school, way back when, we were thinking that it took thousands of years for an ice age to begin. But in the late 1980s, there was a group called GRIP, Greenland Ice Core Project, and they drilled cores, instead of into the ocean floor, they drilled cores into the ice in central Greenland. They went down more than 2 miles into the ice and then pulled up these cores that were about 4 inches in diameter, and they were able to look at those cores and see what happened as much as 250,000 years ago. They discovered that every ice age in the last 250,000 years, and I mean every single one without exception, began in less than 20 years, sometimes in less than 3 years. And they did it from periods of warmth as warm as today or even warmer than today. There was the Eemian period about 120,000 years ago. Actually, it lasted from about 125,000 years ago to 115,000 years ago. And the Eemian period was even warmer than today's interglacial. And when it ended with a bang, went into full-fledged glacial severity in less than 20 years. So that's what I mean by fast.
That's great. And also, I appreciate what you just said. Could you explain the fact that the glaciers are growing? Because what I've heard is that the glaciers are shrinking. What is the story, and how does one verify evidence of that?
Well, that drives me nuts because I keep seeing pictures of melting glaciers, and, we're just not being told the truth. When I do radio interviews around the country, I ask the host if they are aware that glaciers are growing right here in the United States, and almost invariably they've never even heard of that. But in California, on Mount Shasta has 7 glaciers. All 7 glaciers are growing on Mount Shasta and have been for 50 years. Some of them have doubled in size, but we're not being told about it. In Washington State, on Mount Rainier, there's a glacier there called the Nisqually Glacier. In the 1920s, I believe it was 1929, but anyway, the Tacoma City Light began measuring the Nisqually Glacier because they needed to know what water levels were going to be coming down the various rivers in order to generate their electricity. So the Nisqually Glacier is the most measured glacier in the northern hemisphere. The Nisqually Glacier is growing thicker at the rate of 18 feet per year. And yes, it had been receding, but since 1998, the Nisqually Glacier has been advancing. The Emmons Glacier on Mount Rainier is advancing. Crater Glacier on Mount St. Helens, when did Mount St. Helens erupt? I think 1980, May of 1980. There was a great big glacier on Mount St. Helens that totally melted, and the ice and slurry and mud and trees and everything came raging down the Toutle River, so that the glacier was destroyed. Well, that glacier on Mount St. Helens, it's now called Crater Glacier, has made a tremendous comeback. It's now bigger than it was in 1980. But are we hearing about it? No. Glaciers are growing. Glacier Peak in northern Washington, glaciers are growing. Mount Shuckson in northern Washington, glaciers are growing.
Why, for example, do I read that the Arctic shelf is receding and pictures of polar bears are seemingly being taken, falling into the water because the ice is melting? What is occurring that is manifesting pictures like this and information like this?
Part of the reason is those pictures of polar bears were taken in August when the ice melts every year. So that's part of it.
And I heard it's on the eastern side of the Arctic.
Well, what I look at, now I know that some of the Arctic ice has been melting. I agree with that. It's like in Antarctica, the ice in West Antarctica, which is a peninsula sticking out into the ocean, that's melting. But the ice in the rest of Antarctica is growing thicker. It's a little bit like saying no one seems to realize how big the Antarctic ice sheet really is.
How big is it?
Well, we look at the globe, and you just see this little tiny area of ice down at the bottom of the globe. The Antarctic ice sheet is twice as big as the continental United States.
Wow.
The area where the ice is melting is tiny in comparison to that. The comparison I make is if you were looking at the entire United States being covered with ice, and then half of the ice in Oregon were melting, that's essentially the percentage we're looking at. So the ice is melting in a half a state, and our headlines are telling us that the ice is melting all over.
It's out of context, then, is it?
It's not true. Now, in the Arctic, I agree that it appears that the ice seems to be melting, but even during the depths of the last ice age, the ice in the Arctic was not much thicker than it is right now. And that has had scientists confused for a lot of years. How could that happen that